This is lesson 3 of module 2. Our I can statements are, I can use fraction bars and area models. Remember, those are just more detailed tape diagrams to show the division of fractions by fractions that have the same denominator. I can also connect the division of fractions to the multiplication of fractions. We're going to start with the opening exercise. Draw a model to represent 12 divided by 3. You guys know how to do a tape diagram for 12 divided by 3. This whole thing is 12. We're splitting it into 3 pieces, and 12 divided by 3 is 4, so each piece is 4. Next one says create a question or word problem that matches your model. You can come up with anything. Jimmy has 12 apples and he's sharing them with 3 of his friends. There you go. You need to come up with something different. Okay. Go ahead and pause the video and fill those in if you didn't do it as I wrote it on the board. Next, we're going to move on to example 1. Example 1 wants us to divide these fractions. The same rule applies to what I told you yesterday. You can still, when you write it in expression form, you can still do this. You can still do it this way. Flip that second number and multiply. That way always works. Okay? But if you have to do it with a tape diagram, this is what we did yesterday. You do that and you divide it into 9 sections. And then you're using 8 of them. And then you want to know how many sets of 2 fit in that 8. So your answer is 4 because you have 1, 2, 3, 4. And if you had simplified this, you would have gotten 4. Take a minute to write that down. And example 2 is pretty much the same thing. I'm only going to do this one with the tape diagram because I think you guys are getting pretty good at doing it without it. We have 9/12 divided by 3/12. You start by drawing your tape diagram. You have 12 pieces. Okay? We have 9 of those. Now we want to see how many times can we get 3 cubes out of that. 1, 2, 3. Our answer should be 3. If you had flipped that and done that multiplication, you would have gotten 3. So if you had done 9 over 12 times 12 over 3, you would have gotten 3 when you simplified. Example 3 is pretty much the same thing. So if you feel like you've got it, go ahead and skip it. It's okay to skip this one. If you need to practice, do it. Here's our nice little tape diagram. We want 9 pieces. We have 7 of those. How many times can we get sets of 3? Now this one is a little bit different because you have some leftovers, but that's okay. Your picture should look like this. And then you have this one little guy left over. He's just kind of hanging out on the outside. So that means that your answer isn't going to be a whole number. You have 2 whole sets of 3 and 1/3 of a set of 3. That's your answer. Okay, because you have one of these left over out of a set of 3. Okay, we're going to move on to our exercises. I want you guys to pause this video and take 15 minutes to do these on your own. If it doesn't take that long, that's great. But there's 6 of them. I want you to do at least 3 of them using a tape diagram. The rest of them you can do however you want. Okay? So go ahead, pause that video, set a 15-minute timer, and do those exercises. Okay, here are our answers. How many fourths are 3/4? Start by splitting it into fourths. And then you have 3 of those. How many fourths are in 3/4? You've got 1, 2, 3. There's your answer. We're going to move on to the next one. I'm going to do the first 3 with tape diagrams. You don't have to do the first 3 with tape diagrams. You could have picked any 3. Okay, so I'm going to split this up into 5 sections. And we have 4 of those. Now, how many times can we fit 2 in there? Twice. So 2 is our answer. Okay, let's let's do this one. Well, this one's a good one to do together. We have 9/4. That's more than 1/4. That's more than 2/4. So we can't split it just into 4. You have to split it into 9 pieces. Okay, you have 9 of those. There's your 9/4. Now, how many sets of 3, because that's our numerator, do we have in here? 1, 2, 3. So our answer should be 3. Let's do the rest of them by doing our algebra method. So we have 7/8 divided by 2/8. So flip the second fraction, because that's step 1, and then you multiply. I'll tell you a trick. If your numerator on the second one and your denominator on the first one are the same, you can make them a 1. You can cross them out and make them a 1. Because, think about that, when you multiply, you can divide by 8 on both of those to simplify it. So you can make it easier by doing it that way. Okay? So 7 times 1 is 7. 1 times 2 is 2. I would be okay with this answer, but I'm going to show you how to simplify. 2 goes into 7 3 times with 1 left over. So then you drag that denominator down. There's your final answer. Okay. So we have 13/10 divided by 2/10. You flip that second one and multiply. And remember, our denominator and our numerator are the same and they're across from each other, so we can cross them out and make them 1s. We get 13/2. Which is the same thing, because 2 times 6 is 12, so that's the closest we can get, and you have 1 left over. So So then we'll do this one. 11 over 9 divided by 3 over 9. Flip the second fraction and multiply. There's those cross that we can cancel. 11 times 1 is 11, and 3 times 1 is 3. 3 times 3 is 9, and you have 2 left over. There's those questions. If you need to go back and follow along again because you got lost, go for it. Next, we're going to go over your exit ticket. This is what your exit ticket is going to look like. Can you zoom in a little bit? The first question says, find the quotient. Remember, a quotient is the answer to division problem. So you need to find the quotient. Do the math on this. Do the number stuff. Then it says, draw a model. A model is your tape diagram. So then you need to draw a tape diagram. I'm going to tell you, pick one to do with a tape diagram. You don't have to do them both with a tape diagram. I'll write it at the top. Do one with a tape diagram. The other one you can do with just the numbers if you want, but you need to do one with a tape diagram to show me you can do it. The second one has the same rules, just different numbers. Don't forget that if your numerator and your numerator and denominator are diagonal from each other, they can cancel out and become ones. And last but not least, once you finish that exit ticket, come back in. Your must-dos are one through 4. Actually, 1 through 7. Remember, they each have multiple parts. You have to find the quotient and draw a model. In the second set, you just have to find a quotient. I also want you to do 9 for a must-do. Your could-dos are going to be 8, 10, and 11. As soon as you're done your exit ticket, this is what I want you working on. Don't forget to turn in your whole exit ticket packet when you're done.